Axonix Intro to Event-Driven Microservices webinar. My name is Sarah Tori. I'm one of the product managers here at Axonic and the producer of Exploring Axon, which is a podcast now coming on tomorrow with the 63rd episode about a lot of the topics that I will be covering today and much more. So a few items before we start this webinar today. It is a fast-paced webinar, so I will be throwing a lot of jargon and information at you in the next hour, so brace yourselves. With that said, we do have other trainings that go through some of these materials in much more depth. We also have other resources such as blogs, Academy, our Discuss platform that can help you really dive deeper into these topics that I'll be talking today. So fear not, we have a lot of information out there that you can access. I have my wonderful colleague Drew with me today, and he is present on the chat, and you can ask any information that you want to get from us about our webinars and other educational material and resources from him, and he'll be happy to direct you to the right places. Lastly, this webinar is recorded, so you can always go back to it and rewatch it. We also do this once a month, so if you want to come back and see me again presenting this live next month, by all means, please do. I'll be more than happy to see all of you. So let's get started with our agenda. Oh, one item that I forgot to mention is at the end of this webinar, I will share some of the other webinars that are coming up this month, as well as a feedback form. We would really appreciate it if you could spend a couple of minutes and fill out that feedback form and send back to us. That is the only way we can improve our courses and webinars moving forward. So we really appreciate your feedback. So today we will be focusing on two main topics. One of them is the architectural overviews. I will talk about domain-driven design, command query responsibility separation, as well as event-driven architecture. We will then dive into some Axon-specific things. I will show a few code snippets there, but if you are not a developer, fear not. They're pretty self-explanatory and simple to go through, and there are a few of them, so not too many. Now let's talk about the architectural overview, the first one of which being the domain-driven design. So these are terms that were introduced by Eric Evans back in 2003. And these, even at the time, were not newly introduced items or notions. They came from previous patterns studied by other architects and software developers, such as responsibility-driven architecture, other heuristics as well. But let's go ahead and dive a little bit deeper into the meanings of them. So domain-driven design, which I will refer to as DDD throughout this course, revolves around the domain model and makes it the center of every application. And you should regard the domain model as the foundation of every DDD-centric application. What you will notice is that a growth in complexity within the application is accounted for usually by a badly designed domain model. So it's very important to put a lot of emphasis and focus on designing these models. Now, how are we going to do that? Let's first focus on what a domain model actually is. These are the definitions that come strictly from the Blue Book written by Eric Evans. The book is titled Domain-Driven Design. And if you're interested in reading it, please do. It's really worth checking out. However, it is a bit abstract. There are other resources that you can find online as well to help you with understanding of some of these terms. But he defines the domain basically as a sphere of knowledge, influence, or activity. It is the subject area to which the user applies a program, and that's the domain of the software. And he describes a model as a system of abstractions that describes selected aspects of a domain and can be used to solve problems related to that specific domain. If we look again at example, let's say we want to create an application for the needs of a music school, for instance. Your domain basically is everything that is required from the business side from this music school that should be put into this application or your system. So that is your domain, the business requirements of what's needed. Within this domain, though, you can have various models. For instance, you can have a model that only deals with handling payments. You can have a model within this domain that only handles scheduling lessons and so on. So model only focuses on specific aspects of your full domain. So as I mentioned, the model contains the concepts of the client's domain that are needed to solve a specific problem. Again, the payment problem or the scheduling problem. So it's not just a description of the software, but the entire problem which needs to be resolved. Again, it has to do a lot with business problems. And the domain model never really contains the concepts that the client doesn't really care about. So it is just a model, and only selected aspects of your problem are necessary within this model. Let's look at a different example. Let's say this old picture of planet Earth, let's call it the world, is our domain. Now, within this domain, you can have various models. Let's look at a specific model here. By just looking at this model, you can draw certain assumptions. You can see, for instance, that there are grids put on the bodies of water. You can also see that the Americas are put at the center of this map. You can also see that this map is disproportionately sized. For instance, Greenland is a lot bigger than it really is in real life. So what is this model specifically trying to solve within the domain of the world? This model is called a Mercator projection. It shows these grids on the seas and bodies of water to solve a particular problem in sea travel. So for instance, if you put a point on one part in Asia, you can put another point on a part in Canada, and presumably you can place a line from point A to point B and figure out the distance and how long it would take you to get to point B, for instance. However, if this model is used in other domains, for instance, some of you may have seen this specific picture in your textbooks as a child in school. And if so, within that domain of educating children about what the world looks like, this is an incorrect model. And this is not what should be placed in that domain because of the disproportionately sized continents and countries. So this model within our domain of sea travel within the world is emphasizing on the oceans through these differently sized rectangles, which in reality, they're all the same size. And these rectangles then are sized so and placed so visually so that you have the direct lines of travel over a sphere. And therefore, they maintain a constant compass course. We will be looking at some of the building blocks in DDD. There are other important information in domain-driven design that I highly recommend you looking into, such as bounded context or ubiquitous language and things of that nature, because they will very much help you in the design and discovery part of your actual domain. But we will be covering these building blocks throughout this webinar. Let's talk about entities first. Entities are objects that are not fundamentally defined by their attributes, but rather by a thread of continuity and identity. I'm assuming a lot of you are already very familiar with what an entity is through your coding experience. However, this is more of a formal description of what entity is from a DDD perspective. Identity means that your entity is uniquely identifiable at all times. And we will see the difference between entity and value objects here. Value objects, on the other hand, have no conceptual identity, but they are fundamentally defined by their attributes and they are immutable. And you can define them by their state they're in. Now, so if you want to basically have a new state of an object, you can just recreate your value object. You don't have any identity in your value object. And again, these are immutable, and we'll talk a little bit about that moving forward. So let's look at another example. Would you say a human being is an entity or a value object? And let's give it just a few seconds, and you can put your answers in the chat area. And don't be shy. So whatever you think, just go ahead and place it in. So let's look at some of the definitions again. So entity, again, you have an identity for it, and you can say, okay, so as a human being, we all have some way of identifying ourselves. Your name, your social security number, your birth certificate ID. There's a way of being identified. And we are identifiable even if things within us change. For instance, if I dye my hair a different color tomorrow, I'm still Sarah. That part doesn't change. So we could strongly argue that human beings are indeed entities. However, just as is with anything in software, my favorite answer, it depends. It depends on the context in which you're in and in domain that you're talking about. Because let's say we are in this particular domain, in this particular context. In this case, we can argue that human beings are not entities and they can be value objects very easily, because in a case like this, as long as a human being, a person, can sit behind the computer and do the needed tasks, it does not matter who they are, what their thread of continuity is, or what their identity is, they can easily be replaced. So if a person sitting, let's say, on the second computer on the right, tomorrow decides that they found something better, which I hope they did, so they're not sitting in this cramped cubicle situation, they can go ahead and find a new job, and the company can easily replace them with another person who is capable of doing these tasks. So in this particular case, you can say that, yes, it depends, and human beings can indeed be value objects as well. Now let's look at another building block, which is the repository. Now, the repository is a mechanism which encapsulates storage, retrieval, and search behavior of a collection of objects. Why is a repository an indisputable member of the domain? Well, because the domain and eventually the model within that domain defines how to retrieve the right object from the storage. You don't have to search for value objects because you can just recreate them. And there is no identity, so you don't have to search an existing version of it. How the repository technically retrieves these objects is not part of the domain, because the business doesn't really care how this happens as long as it does happen. So the repository building block is targeted towards retrieval of identified objects like entities, but a bit also specifically towards the aggregate. Now, the aggregate should be described as a group of associated objects which are considered as one unit with regards to data changes. Also, an external reference to this group of subjects are restricted to a single member of the aggregate, which is called the aggregate root. And finally, a set of consistency rules apply within the aggregate's boundaries. So really, an aggregate is a group of value objects combined in one thing. If there's a data change, you want to act on the entire aggregate in regards to this change, because maybe several things have to happen in one go, and they have to be done as an atomic change from an outside perspective. So let's look at a real world example. We can take an example of a car. We can say a car can be an aggregate. The vehicle identification number of a car can be regarded as your aggregate root. So that's the only basically data that needs to be accessed from the outside world to access this aggregate. Secondly, there's a single, there are several consistency rules involved. For instance, if you push the ignition button or turn the key, you're expecting your engine to start running. Or if you press the gas pedal, you're expecting the car to move forward or move faster or backwards, depending on which gear you're in. And lastly, you have various objects within this car that make it a whole. So for instance, you have to have a steering wheel, you'd have to have a seat, you may have doors, windows, and so on. So those all have to be kind of encapsulated in one place for the aggregate to function as a whole. Now, there are some debates within our company and sort of outwards as well as to whether or not the aggregate is really necessary, or what are the bounds of the aggregate, and whether or not you can get away without having an aggregate. So there's a lot of debate that's going on, and stay tuned, because we will be talking more about aggregates, not within this webinar, but later on within the next couple of months, I'm assuming. So very interesting things coming up about where you want to put the boundaries around your aggregates and whether or not you need an aggregate to begin with. But let's stick with this aggregate for the purposes of this webinar for now. Now, finally, let's look at events. An event is a notification of something that has happened inside of a domain. For instance, a flight has been canceled, or an email address has been changed, or a text has been sent. As you notice, I'm putting all of this in past tense because events are just notifications that something did happen in the past. So because it is past tense, it's part of the history, and therefore it is immutable. Now, the word event is used various ways within various contexts. So a lot of times people refer to events as something different. But in the purposes of talking within domain-driven design, events are immutable, past tense, and they're just notifications. Now, events are both fundamentally immutable, but also functionally as well. And event handling is conceptually asynchronous. And that just means it's kind of like pub/sub. You just publish your event, and anybody who can handle these events will go ahead and handle them. You don't really care who handles this event or when it gets done. And that is why it is eventually consistent within the model, which we will explain a bit later. Now, great. Let's talk about CQRS, or command query responsibility separation. It's also an architectural pattern. What it does, it separates your application into two main parts. One of them takes care of your business logic, basically. Your updates, creates, the intent. Those are your commands. The other part takes care of the information, either storing or retrieval of that information. So that part is the queries or projections. So the command expresses, as I just mentioned, the intent to trigger an action within the domain. And the intent is very important because the model might decide against this operation. And also, we have the query going into the query model because the query describes the request for information or the state. And there's another building block, which is the events, which we will see here in just a moment. So going a little bit deeper into the notion of CQRS, it allows us to create two dedicated models for two distinct formats of a problem. On one side, you have the command model, which is in charge of executing tasks maybe as fast as possible. And these tasks are primarily expressed as dedicated forms of operations. And the only data the command model needs is the information required to drive that decision. And all of this makes the command model the main point for business logic because it decides whether a decision, a task, or an operation can be performed. On the other side, we have the query model or projections. They're focusing on delivering as efficiently as possible. And to this end, we would typically denormalize our data because you want the data being stored to be as close to the data that is being requested. And this brings the notion of, again, denormalized data or table per view, which we will see in our diagram here in just a moment. When we're looking at command side, we really don't care what goes on inside of that command side internally. We do care on the engineering side a lot, but when just looking at the models and what needs to go in which, we don't care about the inner functionality of the inside of what's happening within each model, whether it's on the projection side or on the command side, as long as they are in two very well-defined models. Now, in between that, we have a UI or a client, which basically make this one conceptual application. So Looking as to what can go inside then, the command model, as you can see, shows more complex models and more boxes that are connected to one another. And this is so because the command model is driving the decisions. And for that, the consistency boundary is extended between different entities and value objects, for instance. It is very important to define those boundaries within your model as well. And that's because later on, if you want to expand, you have an easier time. And I will go through that as well. And the notion of aggregates and interconnected objects are shown here because the state changes happen inside of the command model. On the other side, the query model, as you can see, has less connected boxes with one another because, again, we're going back to table per view or denormalized data. So we want your data to be stored as it's needed. So in essence, we have made two distinct groups of domain models this way, both of them still very much part of the same application, but only selecting the right aspects from the domain to resolve the issue that you're trying to solve. And now what goes on inside of the arrows is on the client side, you can see that you can send commands to your command model. And also on client side, you can send or request for information, and then the projections can send the request back to the client. And somehow, though, these two models have to be synchronized to one another because the changes that are happening in the command model side will eventually have to be visible on the query side as well. And for that, we can use three different approaches. We can use the shared data source, which basically uses the same database with persistent views, but this pulls the problem back into the data source layer. May not be what you want. Another way is you could also use stored procedures to on your database. So changes in one table trigger changes in other views and tables, but this kind of goes against what we talked about, denormalized data and table per view. So this may not be ideal either. Lastly, we can use an event-driven architecture, and as you rightly so guessed, this is the part I'm going to focus today. So changes happening in one part are marked by an event, which is used on both ends to update the state. Looking back at this diagram, now we can see how that happens. Now, events that are published by the decision-making part of your application on your command model can be used to update your query side. And as you may recall from the conceptual description of events, this makes the process asynchronous and therefore eventually consistent. And this word eventually consistent is a bit nerve-wracking for some, but the thing that I always try to remind myself is eventually being inconsistent is actually scarier than eventually being consistent. And to that end, there are ways that you can handle this sort of, let's call it fear, a bit better. So let's talk about event sourcing and what that means. Event sourcing defines a storage method for the command model only and not the query side. The command model is stored through means of distinct changes, essentially different events. To retrieve your command model from the repository, you would replay all of your events applied by that particular aggregate that's published those events. It's important to note that you would do this against an empty instance of that aggregate type. And doing this replay activity against an empty instance means that you are recreating, or as we like to call it, rehydrating the state of your aggregate step by step. So what we are actually doing when we are using event sourcing is that it's not just the query model that changes through events, but also the command model as well. And this makes it so that we have a single source of truth, which are the events, and they create every model contained within this application. Now, the event store is a very important aspect of doing event sourcing because we do need to somehow store all of these events. The main focus of the event store is to append events, which means no updates or deletes. So a lot of times you may hear in our other resources, you can't use CRUD because you can't delete or update. You are only allowed to append to the event store. And this makes sense because the events are immutable and they're the things of the past. And because you can't change history, neither can you change your events. With that said, we can use Axon Server, for instance, which is a purpose-built event store. And it's also a message router. But we won't go into details of Axon Server, unfortunately, during this webinar. But we do offer free 2-day webinars on Axon Server. It's not whole day. It's only, I think, 2 hours per day. So you can really see the inner workings of Axon Server and how it actually communicates with application, what it's made of, and so on. Axon Framework also supports the usages of relational databases through JPA and JDBC, or other forms of databases such as non-relational databases like MongoDB. But using these generic databases basically can have downsides as well, because they are in charge of doing other things than just storing your events. So maybe using a purpose-built event store is a better route for you in your specific use case. So I highly recommend that you check out various options that you have and pick what's best for you. We also have another product that we're just launching this month. It's in the beta format at the moment, and it's called Axon Synapse, which allows you to connect with Axon Server from any application, regardless of a language that it's written in. Because Axon Framework is JVM framework. Basically, it uses the Java or Kotlin within this framework, but you can use applications that are not within the bounds of Java or Kotlin to also connect with the server. But I'll talk to you a little bit about what we offer for Axon Synapse later this month as well in terms of the webinar. So we use events to create our query model, but also to recreate the command model. And that means we'll have a single source of truth. And conceptually, that's great, but also for business reasons, this is valuable. Because by following this concept, you can reuse the events in the event store for alternative solutions in the future. And this way, you have less information loss, for instance. You have a way to really audit your logs and find out how you got to this final state exactly as you did. So this is great because you have less information loss and you can see basically the flow of how everything's come to be. Lastly, an event represents deltas because of that, you can increase performance, because events are the only part that you have to store as opposed to a bigger chunk that needs to go into your database. And I'll show you an example here in just a second. And you can even cache the results to provide big reads at times if you needed to. As promised, let's look at this example. On the left side, we have your regular state store approach. And you can see on that side, you have an ID number with an item, which is a deluxe chair for a certain amount. And your final status is that the return shipment received. You have no other information when you're only looking at this table, basically. On the right side, you can see the event sourced approach. You can see exactly how everything is happening. And because these are smaller chunks, it's a lot easier and faster to store them. So you can see that there was an order that was created with an ID number. An item was added. Another item was added. One item was removed. Order was confirmed. Order was shipped. Order was canceled by the user. And then the shipment for the returned order was received. So as you can see, you have less information loss. You also have a great audit log. You're not missing any information here, as opposed to the left side where you really don't know how you got to where you got at the end. And lastly, you can conclude that this is a performance increase. The separate events on the right are much shorter and smaller than the entirety of that entity on the left side. And this can help you adjust or change your model to better help the business, because you can also alter your customer experience as well. You can basically set out a group of your researchers to find out why 2 chairs were picked and selected, why one of them was removed, and why in the end this order didn't work out for the customer. So you can do a lot of experimentation with your customer experience. You can change and adjust as you need within your business, which makes it a lot easier. So this is all great, and it also brings us to almost the end of the architectural overview part of today's webinar. Now we can combine our knowledge of CQRS, DDD, and event-driven architecture and event sourcing on this one diagram. Here we have the building blocks or the messages. We can already see the idea of CQRS coming back as well with the view of the client or the UI sending commands and queries to two distinct parts of the same application. And there are events being published. The command model we have upright. It consists of a number of aggregates, entities, and value objects in them. And then we have the repository on the as the abstraction layer to retrieve our command model. So Axon server specifics or your event store basically resides there. Because remember, it's only for the command model to store your events from the command model. Now, on the projection side of our application, on the bottom side, you have another domain model. And again, you can see those aggregates, entities, and value objects. Even though they look similar, they really have nothing to do with each other. And those aggregates are completely different from one another. White papers, how to configure? Yes, we do have white papers. So Drew, if you can provide information on that, that'd be great. So the projections of our application are, as I mentioned, at the bottom right. You can see some similarities with your command side, but again, as I mentioned, they're not identical because they are focusing on different problems at hand for each model to really focus on that particular model. Now, this leaves me with the big question of why. Why are we all doing all of this? This seems a lot. So let's see why. Why does it matter? Let's say you have a fantastic idea and you want to start a greenfield project. You have this wonderful plan that's going to generate you a lot of money, and it's a great business idea, so let's go for it. You are projecting or thinking that in the future, you're going to have a lot of customers bringing you a lot of business. And for that, you would need to scale your application. And what better way to do that than go straight to microservices, right? However, doing microservices can be a little bit tricky. You may end up there directly, fantastically. That would be the best case scenario. However, in most cases, we see that people end up in Death Valley. And instead of coming up with a wonderful distributed system and microservices with clear APIs and so on, we end up with distributed, let's call them balls of mud. So instead of doing that, instead of directly going for microservices, why not start differently? Start with a monolith with clearly defined components in there. From there, you can then go on and decide if you want to modularize and take one of the modules outside of your main application and put it in a different system to deploy and so on. And if that works really well, you can even take another one of your modules and expand it to different ones and make that even more expandable for your customers' use. And so these happen because you are slowly extracting your well-structured components into separate services. And this eventually ends up, as your needs arise, into your wonderful microservices approach that you wanted to have in the first place. And if you decide, you can even go cloud or serverless altogether. This is the approach that we call within Axonic as evolutionary microservices approach. And there's one thing that makes it possible, and that one thing is called location transparency. Location transparency is actually a very well-known concept, I suppose, in other communicational systems like telecommunication and so on. What it says, basically, it's a networking process. It's a concept that components should not be aware nor make assumptions on other components' locations that they interact with. The idea behind doing this separation of knowledge where each component is makes it so that you can remove or scale up certain portions of your application when you need them to be. When both models aren't location transparent, meaning using each other's components, this becomes very difficult to do, and you basically lose this option because they are coupled with one another. So first you have to separate these components from each other to be able to increase and scale up as you go. And arriving at this wonderful location transparency heaven has to start with a good API design. Let's go back to this diagram that we have. And here we can show the boundaries which make it possible to clearly separate our UI from the command side and from the query side. All of them are three different components that you can really define and separate from each other. So this makes the commands, events, and queries the good API that's required to follow your true location transparency method. And the message buses are the means to just send messages without knowing what piece of the application is actually going to deal with them. And we do have some great blogs on how to do this, so please check out our website for those. Now, let's look at some Axon Framework specific items. Again, we will be looking at a few code snippets, but again, fear not, I will explain through them as we go. Let's first talk about command handling and aggregate design through Axon. Looking back at this architectural overview, I'm focusing on the top portion, which is our command side. Let's first talk about what a command handler actually is. The concept of a command handler is a component which accepts incoming commands. So if you remember from the UI or client, you send a command. Now, upon receiving this command, it consults the command model and publishes your events. And it may also update the command model either directly or through your events. Now, as we pointed out earlier, the command model only ever contains data that is required to decide whether or not it can execute that command. In Axon, a command handler manifests itself as an actual component which is subscribed to a command bus to handle a specific type of command. The function to actually receive the command messages are annotated with the add command handler. Surprise. The add command handler annotated function can reside on a singleton component or directly on your command model or your aggregate. In an actual Java function, you can see that it looks as such. The command handling function is subscribed to the command bus, which will handle the join room command. And just to give you the context, we're talking about a chat room, which we'll see here in just a second. Now, from here, we are going to make a jump at having these command handlers directly on the command module, which is our aggregate, which is basically marrying the concept of DDD, which is driving a group of entities, with the CQRS concept of dedicating different parts that are handling different operations. So in this example, our aggregate is called chat room. Welcome to the 90s. For configuration simplicity, we are using Spring in our samples. The aggregate annotation is actually a Spring stereotype, which notifies the Axon Spring auto configuration to wire up the necessary infrastructure, such as command handlers and the repository. Now, the aggregate identifier annotated field points out the identifier of this aggregate. So this is the single point of reference to the aggregate, such as your vehicle identification number that we talked about in your car aggregate sample. So this makes the chat room the aggregate root as well, because it contains that external reference towards your aggregate from the outside world. Then we have the command handling function, which is saw, which states the intent to join a room. And as you may recall, the command is the expression of the intent to perform some operation. We want to operate this change. We want to actually use this change through our system with events because we are following the event-driven architecture. Now, to that end, we need to publish an event from within this aggregate context. For this, the framework provides the aggregate lifecycle apply method, Sorry, I can't talk today. This is a static method that resides here in the aggregate lifecycle. So later on, it can be used for our sourcing purposes when we do event sourcing. In code specifically, this function call will publish the room joined event. And as you can see, the event is in the past tense. Now, this is how the aggregate or within the command model is event sourced from its own events. To explain this, let's look at this chat room aggregate again, but now we can show two different methods. In this example, we have a command handling constructor to create a chat room, and this is there for the initiation point of this aggregate. In addition to that, we have an event sourcing handler, and this is very important. I like to stress this, that the event sourcing handler happens within the aggregate inside of the command model and not your projections. So the event handlers are in the projections, which I will show you in just a second, but the event sourcing handlers are within the aggregate inside of your command model. So the state changes in your command handler are a big no-no because they will not be picked up when you're replaying your past events, when you replay your aggregate against this empty instance. So within your aggregate, you will achieve a clear separation of concerns as well. So we kind of going back to the CQRS in a micro level here a bit. The command handlers are there to drive the decision-making logic and publish an event to note the decision as being fact. The event sourcing handlers, on the other hand, are there to adjust the state of your aggregate. It is important to note that these event sourcing handlers will only handle events from this particular aggregate instance, which means no events published by other aggregates. And as mentioned before, this is a requirement for event sourcing, which is that you create an empty instance of your aggregate and replay that aggregate's events to recreate or rehydrate your state. So we've got our command handling functions. We still need to get the actual command messages to our command handling components functions. And to do so, we are dealing with the aggregate as a command model, and we have a single entry point into that aggregate, which is that identifier that we have. And this identifier should also be present on the command message you send, which is done by annotating a field or function with the @target aggregate identifier. And this tells Axon where it can get the identifier, which points to a single point of reference for this command model this operation should happen on. And as you can see, you can also create Kotlin classes for your messages. And I love these because they provide a much shorter annotation and the option to group several of the commands in just one single file. Now, we talked a lot about handling or receiving the commands and how to route them, but we also need to publish and dispatch them. There are two different ways that you can do them in Axon. One is directly onto the command bus component, calling the dispatch function. And the other way is using the command gateway and its send or send and wait functions. And the command gateway actually gives you some extra handles on how you would want to send your command. So this might be a better choice for you for publishing and dispatching your commands. And this command gateway actually does this by sending your commands either non-blocking with returning a completable future or with a callback, or blocking with or without a timeout. So let's move on to the query side, which is the bottom side of this diagram. For that, let's start by talking about event handlers. As you may mention a couple minutes ago, I said event handlers are happening on the query side. And these are similar to the idea of your command handlers, but of course, with the events, an event handler is a component that handles your published events. The event handler can then, for example, create or update your projections. It can trigger external activities such as sending an email or a message, and it can also manage a complex business transaction. In Axon, this is done by sagas or process managers, which unfortunately we will not go through them today. So more specifically in Axon, an event handler is a component which is subscribed to the event bus to handle a specific type of event. By subscribing, it will receive or pull the events from the event bus to handle. And we also have tracking event processors, but for those, I will send you to the reference guide to read a bit more about that. Now, code-wise, this is done so by, as you guessed it, at event handler annotation, which looks as so. And here we have an event handling function for the room created event, again in past tense. Now, putting it more concretely, you could have a Spring Bean with add component, and the add event handler annotated function on is called automatically when a room created event is published. Hopefully, this is pretty straightforward. Now, let's discover what you can actually do when handling events, which is creating and updating your query models. Now, as discussed earlier, we would optimize the query model to answer the queries as directly as possible for the problem at hand. We talked about denormalized data. And the models are focused on data, again, denormalized to map the needs directly. And of course, the model is updated by an event handling component. When setting up your query model, you should consciously optimize them for the requirements at hand for that specific model. So if, for example, you want to be able to quickly return the results as the query comes in, you would store the view as it's required. So for example, as a JSON representation. This increases your query performance and flexibility, but you lose time on updating the views because you would need to do string adjustments. If you need to efficiently store your data, you would probably not store the view as a JSON string, of course. You would then lose the exemplified performance gain in favor of a storage space gain. So in short, there are things you can optimize for in which you should really think about and do some research on based on your requirements at hand for those query models. And the fact that we are decoupling the data, you are having this flexibility to use them for the exact use case that you have at hand. Let's look at an example. As we talked about, we should denormalize the tables to be as optimized as possible for the queries your clients would need. Let's say we want to be able to query a complete order and return it immediately instead of having to join the order and the customer tables, for instance. In this scenario, you would probably not create the table like this order header table because it is not denormalized and wouldn't tailor to your requirements at all. Instead, you could optimize for complete data retrieval based on one order ID. In addition to that, the order ID is intended for the UI. So as you can see in this example, you would just have a table containing an ID or several IDs and the complete projection. This is obviously optimized for full data retrieval based on one single identifier. The heavy lifting, so to speak, here is now happening when creating the projection. But when are queried for, the responses can be sent back very quickly. Now, the missing link in here, which is the query handling. A query handler in Axon is very similar, again, to your command handlers and event handlers, although this time it's about the specifically query message and the query response that are registered to the query bus. Similarly to event handlers, query handlers are functions on singleton components. In code, you would use the add query handler annotation in the function. Now, the first parameter will, again, be the type of the message you can handle. But here, the return type of this message is extremely important as well, because that will become your query response. In a more detailed example, you could have a query handling component like so. This class is capable of handling two types of queries. One is sum query, returning some response, and the other is the sum list query, which returns list of sum list responses. And it shows that you can have a single result or several results. Just like the commands, we need a way to dispatch or publish the queries throughout our application. And this is done so by a query bus or a query gateway. And similarly to Command Gateway, the Query Gateway gives you a bit more convenient infrastructure component as opposed to your query bus. Now, it's important to note that the response that is contained in it is contained in a completable future. And in addition to providing the query payload, also known as the details of your query, you also need to specify the response that you're expecting. And you would also need to specify an instance of, which gives you a single response, or multiple responses of, multiple instances of rather, which give you multiple results. So Axon provides three types of dispatching your queries. One is point-to-point query, which basically means you send a query, you receive a response. Scatter-gather is when you, let's say, send that same request, and anybody who has the information can send you several responses. And the last one is your subscription query with a single destination for your initial result with future real-time updates. Now let's look at each one of them. Point-to-point is the simplest one. As I mentioned, you send one request for a price of an item, you receive a price for an item. Nothing to it. Scatter-gather query, you're asking the same question. What is the price of an item? Here, you can have an if statement. For instance, you can get a result saying that the price is $199. But if you have a VIP customer, the price is lowered for them to $149. And for this type of query, you can even have other if statements. For instance, if you have a sale or a special event coming up, you can put another if statement saying that if this event is happening, bring the price even lower to $99. However, in this part, you do have to provide a timeout because sales or special events don't last forever. So you really do have to have that timeout within your code to show that on such and such date and time, this query response is no longer available, and it just simply goes away. Now, on the subscription query, it's a little bit different. It works initially like a point-to-point query. So you're asking for a price of an item, and you receive the response of $49. Now here, you can have updates, specify the new price based on your requirements. On the receiving end, then, you can decide how to deal with these deltas. So very likely, we will take the initial result and sum the deltas with it to come up with the actual price that you have now. So again, you send the initial response, and based on your future updates, this price can change to a new price. Now let's look at what it looks like in code. Point-to-point and scatter-gather queries are very straightforward. Work with what's already said about update handling and dispatching queries. All of that doesn't currently sort of means to publish updates when the query model changes. And for that, the subscription query requires you to use a query update emitter. And as you can see in this example, you have a regular query handler annotated function for the room message query. And this will return the initial result of your subscription query, similarly to your point-to-point query. But in addition to that, you now have wired a query update emitter in this component. And the emitter is, as you can see, called upon updates of the query model in the message posted event handler. As we synchronize our models through events, the query model is then updated by an event handler. The event handler is in charge of emitting query updates in this scenario because it knows best when this model is updated. So again, lots of information coming at you in less than an hour. So to summarize, we did talk about the architectural overviews, DDD, CQRS, and event sourcing. We then talked about how we can marry all of these topics together within Axon Framework, for instance, in our case, and what annotation and handlers you have to really be able to build an application based on two separate models and connect them with a UI or client in between, and use the events to update both your command and query models as well. So as promised, we do have other resources and webinars coming up that will dive deeper in a lot of the topics that I talked about. We have a full Axon training that happens, I believe, once every month or once every other month. For that, you can visit our events page. goes through a lot more Axon Framework specifics. We also offer Axon Server free webinar. That's also, I believe, as I mentioned, done monthly. And again, 2 days, back-to-back days. Each day, I believe, is 2 hours of really talking about nitty-gritties of Axon Server and how it works. As promised, we have another webinar coming up at the end of the month that talks about our new product, Axon Synapse, which can connect the applications that are not written in JVM, Java, Kotlin, specifically that can use Axon Server. And the Synapse provides you with the tools to be able to really use Axon Server or use event sourcing if you want to in your systems as well. I'm presenting that webinar with one of my colleagues in our engineering department, so please check that one out. It's 1 hour of explanation followed by a short demo. And we have a hands-on workshop if you are in Houston area, if you're in Texas and would like to travel to Houston and check it out. It is also free. It's a 3-hour workshop that is presented by our CTO, Allard Bause, and myself. In the first portion of this workshop, we introduce many of these architectural concepts that we talked about today, but some of them in a bit more depth. We will then go ahead and sit together and have a discovery phase using event modeling and a bit events storming, if you're familiar with those concepts. So we will bring in our attendees to really talk about how we can model an application. And on the third portion of it, we will provide you with basically a skeleton of an application where we can then bring in the notions of what we talked about within our discovery and event modeling section into the code and see what it looks like in an application, which we will then run locally within Axon Server as well. So if you're in the area, please join me and Allard later in the month on February 23rd. I believe it's a Thursday. We will be offering that workshop. And if not, you can still check out all of our online resources that we have. I mentioned Exploring Axon, which is the podcast that I produce and host. It comes out every other week with a really amazing topic. It focuses both on the business and technical side. So if you're not a developer, again, there's a lot of information for you to benefit from. If you are a developer, there's a lot of good stuff there for you to listen to and get those resources that you need. If you want to play around with building an Axon Framework application, we have Axonic Initializer, which is our happiest place on the internet, which is start.axonic.io. I'm totally stealing that from Josh Long with his happiest place, which is the Spring Initializer, but we have our own. We do have Axon Academy, which provides you with online courses. It's self-paced, so you can take your time going through those courses. We do offer a couple of free courses at the beginning, and if it suits you, you can then purchase the future courses after that. As I mentioned, there's a lot of information on our reference guide. Please check it out. It goes into a lot of details about the annotations and the workings of Axon Framework as well as Axon Server. And last but very much not least, our Discuss platform holds a huge community of our users who are regularly interacting with one another, asking questions, sharing their resources and experiences, even code samples. So please check that out as well. And as promised, the very important part for me, which is your feedback. Please give us your feedback about the information that was presented to you today, how it was presented, if you liked it. If you didn't like it, please give us examples of what you didn't like so that we can fix and improve as we go forward. And with that, with less than a minute left of our time, I'd like to appreciate and thank all of you for being here and spending part of your day with me and Drew. Please check out our events page on axonic.io for other events and workshops in your area. We are a very distributed company. So if you would like us to come to your area, please send us a message. We would love to present these workshops and trainings closer to your location. So please don't hesitate to let us know. Have a great day and stay safe.